find it very difficult to go back, as one of the earlier speakers said, to the energy use of 100 years ago. I've tried to show that there is no shortage of energy around us, but carbon-free energy is not easy to harvest and it's not easy to generate. If we only use the traditional means of harvesting those energies, then there are going to be a large reduction in living standards, I've said here, in the West. And what I really mean is in the developed countries that currently exploit energy. And what I've tried to show is to pick up just a couple of examples. I don't have time to go through many, but there are many technical possibilities to pursue, from the better use of existing fossil fuels, so we get more energy for less emission, to totally new ways in which we can exploit the sun. Solar photovoltaics are only one possible route. And if we look forward and imagine what our world may look like in 50 years, there could be many, many different ways in which we do it. We have a richness of scientific possibilities in front of us. And so I'd like to just finish with this comment. I wish I was starting my engineering career now, because the possibilities for engineers and scientists to come together to address these problems and to produce something that will be of immense benefit to society at large is enormous. And I envy most of you in the audience who will have the chance to take on this challenge, which will be a rewarding one for you and ultimately a rewarding one for the world as well. Thank you very much.
Right. Thank you, John, for the excellent talk on cycles of energy. It was indeed an informative lecture. So now, ladies and gentlemen, I believe you will have many questions for John. So let's head straight to the Q&A session. Can I invite some questions from the floor, please? Yes, please. Please use the mic. No, right the center.
My question is, how exactly do you intend to extract energy from things like, say, fuel cells? I understand that a fuel cell uses water, hydrogen and oxygen, which are recombined to form water and produce electricity. But to get the hydrogen, you first have to electrolyze water, which at the present is the only means of producing hydrogen. Now that won't produce, that will take a bit more energy than the fuel cell would produce. Theoretically, the fuel cell would produce the same amount, but given all the, it can't exactly be perfectly, efficient. So, basically, you don't produce much energy from a fuel cell, you're just using it as a storage mechanism.
Mm-hmm. Okay, well, thank you for the question, and it's a very good question, and your analysis of the situation is correct. We don't have hydrogen mines. There is no source of hydrogen other than by taking it from chemicals with which it's combined, and the most abundant is water. But to answer specifically your question, we can create hydrogen by electrolysis, and if we use electricity to do that from conventional power stations, then there is absolutely no point in doing that, because you will get out about 1/4 of the electricity that you put in. However, there are other possibilities. If, for instance, you generate electricity using wind turbines, which is carbon-free, And if the electricity is being generated at a time when it is not needed, then one theory is that you will use it to generate hydrogen as a storage means, and you will then convert it back to electricity when you need it. And the advantage of this is if you don't do that, then you simply lose the electricity that the turbine could have generated if nobody wants it at the time. But there are other possibilities. You can create hydrogen from hydrocarbon reserves, natural gas, coal, oil, and if you store the carbon, then it's a clean way of taking the energy out of the coal, and that's what I was talking about with the coal gasification approach. But the other approach is you can generate hydrogen from other sources. And I mentioned towards the end of the talk the process that algae use to generate hydrogen using excess sunlight. And another possibility is that we can do it from that form. However, there is no agreed solution and there is no established technology for doing this. And finding a way in which we can generate hydrogen will be very important. I should also say, of course, that developments in battery technology may make the use of hydrogen less attractive than it seems today. Because if we can store an electrical energy in future generations of advanced batteries, then it may be that the difficulties of storing and generating hydrogen and recuperating it from the storage medium are such that we wouldn't want to do it. So to summarise, the reason we're interested in fuel cells is because they are more efficient as small devices than alternatives that we use today. Those that use hydrogen create the new challenge of where does the hydrogen come from. Your question is a very good one. There are some fuel cells, however, that can use natural gas and synthetic gas, and the advantage of that is that they are potentially more efficient ways of conversion than other approaches that we have today. I could actually talk for about 3 hours on your question, so I'm going to stop now.
Okay. Can we have the next question, please? Yeah.
Hi, John. Hello. Hi, John. My name is Sivanesh. I come from Multimedia University. We are from the University's Engineering Society's Overseas Research Program and undergraduate research. And this year, our research is on energy, from megawatts to negawatts and countering energy issues in Malaysia. I wish to touch on the conservation of energy. We all know that Malaysians generally waste a lot of energy in the form of electricity. And taking this hall for an instance, as I speak here, I'm shivering along with all the other audience here due to the low temperature of the air conditioning system. And the same scenario happens in almost all buildings in this country, and this is an evidence of inefficient energy management. Now, my question is, would you agree if this lack of energy, awareness of energy savings is due to the low electricity tariff in this country? Thank you.
Right. Would you allow me to answer a slightly different question? Because I'm not familiar with the electricity tariff structure in Malaysia, and equally I'm not familiar with the political barriers that drive it. However, I would like to give you what I think is a very relevant answer. I was really talking about where we might get energy from. You've raised the question that we should use it more carefully, and I totally agree with that. And from a policy point of view, virtually all countries are now looking at ways in which they can reduce the demand for energy. And this can go in many different ways. We try to develop more efficient electricity generation systems. We try to develop more efficient transport and industrial processes. We try to reduce the need for transport and industrial processes, either by persuading people not to travel or by providing more public transport. And equally, we need to persuade people to use less energy in their homes and their businesses. However, this is very difficult to do because the availability of energy is one of the luxuries of modern life, and it is very difficult to persuade people to stop using luxuries that they can afford. One way in which we try to do this is by developing more energy efficient technologies, more efficient lights, more efficient refrigerators, more efficient air conditioning systems. My own organisation recently published a report on this. There is something that is surprising when you look at all the evidence on what happens if you have more energy efficient technologies. The result is you use more energy. And you use more energy because it becomes affordable to make greater use of energy. The example I always use is that when I was at school, I went on a trip to Paris, the capital of France, which is a beautiful city, and we went round it during the day to observe the bridges and the buildings, because at night you couldn't see them. If you go to Paris today, all those bridges and all those buildings are illuminated all night long. And the reason is that the improvement in lighting efficiency has made it affordable to illuminate them. So people do, because it looks good. It is a demonstration of their advance as a society. One of the issues, therefore, I think, and I think I'm answering your question in saying this, is that there is a need to persuade people to use less energy. But to do that is a research project not for engineers, it is a research project for social scientists, psychologists, and behavioural scientists. It is very, very difficult to do this. It is like persuading people to stop eating their favourite food. So, your question was, do the low energy tariffs contribute to energy consumption? I am sure that if electricity and energy is cheap, we use more of it. Equally, I'm sure if we effectively make it cheaper by offering more efficient technologies to use it with, we will also use more of it. So this will be the great political challenge in the future that will run alongside the science and engineering challenge. How do we engage the population at large to work with us to reduce the amount of energy that we need?
Yeah, thank you. That's a very safe answer. Next question, please. Yes.
I'm from Nottingham. I just want to ask that since you mentioned that now we are should start to switch from fossil fuel to more renewable energy. So, but from what I know now, globally, renewable energy would only supply 0.5% of the total energy consumption in the world. And to start up a renewable energy system, the payback period for that would be quite long and the investment would be quite high. And let's say we switch to biofuel. Most biofuel would reduce the consumption of fossil fuel, but in the other way, the carbon dioxide that produced from producing the energy would be raised up. So is there any way to overcome this?
Okay, well, that's a very fair question, I think. First of all, I'm going to disagree with you on figures. The world energy consumption at the moment is probably about 5 to 6% from renewable energy, if you include hydroelectricity and other renewable forms of energy. But nevertheless, it's a small amount. I totally agree with you. I think, however, your question is based upon using the technologies that we have today. And one of the messages I was trying to give is that the technologies that we have today are really just slight variations in the technologies we had 100 to 150 years ago. There is very little real scientific advance. Why has there been no advance? Because we've had fossil fuels. And fossil fuels are energy dense, they are easily available, they are cheap, and they're very convenient. And as people, we're lazy. Why should we go and try and develop something else when there was no apparent need to do it? One thing I try to persuade people of is the world has today an energy system. And the energy system we have, we did not get by accident. We got it because it was the cheapest and best performing way of meeting our needs. We now are introducing a new element into the equation that says, but it is causing collateral damage, and we need to look for different ways. The argument that I would make is that in the short term, and I think you were probably talking about immediate action, we need to look at maximising the exploitation of the available technologies, wind, solar. We need to look at conserving energy. But in the longer term, I believe that the solution will come through further scientific and technological development. The point I was trying to make was that I view this as an engineer. There's lots of energy out there. We're in a building, you've constructed it, and you've put in systems to deflect the energy that's arriving at the building, to keep it cold, because you want to avoid the solar energy and the concept that it has. I was trying to explain that in my view there is lots of energy, we just don't have the means of capturing it in a convenient form. I believe that there are many exciting scientific and research possibilities that will enable us to do that. So I agree with your analysis in terms of investment in today's products at today's prices. But I do believe as we go forward, we will change the cost consequences of some of the existing forms of energy. More importantly, I have total confidence that I shall retract that statement, that you, in your future careers, are going to develop ways of capturing energy that we today have not even imagined. And that is my answer to you, that I believe that the ingenuity of people will find a solution that today we don't have, for very good reasons.
All right, thank you. Next question, please. Okay, right, sure. Just hold on.
Another question. Is there any compound containing hydrogen that we can extract hydrogen from more efficiently than water? I mean, could there be something that would use less energy to extract the hydrogen from, because perhaps the bonds are weaker, but you combine hydrogen and oxygen to form water? And a second question about those fusion reactors you were talking about. I believe the plasma is going to be hot. I'm quite certain that the casing of the reactor would probably melt. So how do you intend to contain the plasma? Some sort of magnetic confinement thing? Okay, that's it.
Okay, thank you. Well, the simple questions are always the hardest, aren't they? I'll take them in form. The question about can we find hydrogen that is easier to split than water is a very good one, and I can't give you the answer. I can tell you that there are several thousand research scientists in the world trying to answer that very question at the moment in different forms. But of course it is the obvious question to ask. Can we do this more easily? And we're seeking solutions. The answer is that in naturally occurring materials, no. And what everybody is looking at is creating different ways of attaching the hydrogen to other materials in a more convenient form. And the real question is how much energy you need to put in to connect it, and how much energy you need to put in to get it back again. The second question on the fusion reactor is a very good one. However, the plasma at the centre is, yes, it's very hot, but it's also under a very, very high vacuum. The vacuum is such that it doesn't behave like a normal gas. And you can't measure the temperature of the gas in the way of the plasma, in the way you can a conventional gas like the air that surrounds us. You have to measure the energy of the individual molecules in the gas. So the concept of temperature is slightly different. What you need to look at is the energy contained in any molecules that escape from the plasma and hit the wall. And the clever bit of fusion reactors is that that plasma is contained by a complex system of magnetic confinement. Surrounding it, and most of the size, is a rather complicated system of magnets which operate under real-time control, and because the plasma itself is electrically charged, you can move it around using these magnets. And the skill of fusion reactors is you get the control system of the magnets in such a way it keeps the plasma contained and away from the wall so that it doesn't hit it. And if you do allow it to hit the wall, what you describe is exactly what happens. There's a big bang, a big flash, and if you don't do something quickly, it melts. So this is quite a challenging piece of technology. But two very fair questions.
Thank you. Can we have the last question?
So, hi John, I'm Jerome from MMU, from the same program. So, I just want to say that in order to persuade the people that energy savings is important in a country, the higher learning institutions play a big role, which I should say is the backbone of any country in technology and development. So, in the case of IET, I come to know that IET UK is a major advisor for energy policies in UK. So, what I want to know is, to what extent that IET is willing to support the university students in Malaysia in order to promote them and through that promote the whole country to understand that energy savings is much more important at the moment for us to sustain and for a better future for our younger generation. Thank you.
Well, thank you. That's a question that I might simply bounce back to you. I think the need for energy saving is quite clear. The real challenge, as I was trying to say earlier, is not an engineering or a technological challenge. It's a challenge of public engagement and social science. And I think what we have tried to do from the engineering and technology community is explain this clearly to the policymakers. But the policymakers now need to take that on board and decide how to address it. How would the IET support people in countries such as Malaysia? Well, there's a lot of evidence that we make available. There's a lot of technical information. We make available a lot of facilitated technical networks and groups through which this information can be provided. And Chris Chu, who chairs the IET here in Malaysia, I'm sure can tell you in quite a lot of detail about the specific activities that would respond to the point you've raised about local support. But one point I would like to make, and I think this is really very important for the future, the solution to the energy problem I don't believe will necessarily come from the UK or from the United States or from anywhere else. I think the solution will come from the rapidly developing countries such as Malaysia, which are engaged in this field and which have the capability of tackling this without the long history and sometimes barriers that some of the more developed countries have got. And it's one of the reasons that I said earlier, this solution will be found by people like you. And I meant not only young people, but I meant people from countries that can think the unthinkable, because they don't have to cope with the history of the past.
Okay, thank you. Okay, I'll just allow one last question. Yes, please.
Morning, Mr. Loughead. I thought it's about time the senior citizens were represented this morning. I actually have one question. I mean, you brought up regarding the renewable energy and all that. What are your views on CHP? Because I do know that in England you do use a lot of CHPs, but what are the cons of it? I mean, we only read up, and we only know, they only tell us all the good stuff, but what are the bad stuff? What's the downturn about it? And is it readily applicable, and would it be suitable to be used here? Thank you.
Okay, thank you. Well, combined heat and power is simply a way of using the energy contained in whatever your fuel is more efficiently. And the idea is, effectively, is that you seek to use both heat and electricity at the same time. So a CHP system generates electricity, and you then use the waste heat for another purpose. Quite clearly, if you can use it, it is a very sensible way of using energy. However, it depends upon the nature of your electricity system. It's not possible to use it in very large-scale power plants because we do not have good technologies to transport the heat efficiently in the way that we do for electricity. So you must be able to use the heat locally. What that means is that the best CHP schemes tend to be comparatively small scale, and all the really successful ones have been in areas where it has been possible to take an existing demand for heat and regard the generation of electricity as something that is a byproduct. So you see it in certain industries where CHP is used a lot, where there is a big heat demand and they also generate electricity. And you see it in certain cities, particularly in places such as Denmark and Sweden in the UK, in Europe, where they have cities where they have installed plants and they actually generate heat for the buildings and they have electricity as a byproduct. The problem with it is always matching the heat demand and the electricity demand, and it is very often runs into problems because the heat demand is controlled by the owner, usually, of the plant, but the electricity system is not always prepared to take the surplus electricity that you wish to generate. And consequently, there are barriers to CHP which are not only technical, but are commercial and sometimes regulatory. I think that in summary, if you can use it, it is good, and I don't believe there are any real cons, but sometimes it can be difficult to use. But where you can, I believe it is a very good way of approaching the problem, certainly in the immediate future. And just to round off on that, one of the trials that are being run in the UK at the moment is to use combined heat and power at the domestic scale. You may know most people in the UK live in single-family houses or flats where they have their own heating system. We don't have cooling needs in the UK, we only have heating needs. And there is a combination of their heating system with a fuel cell that will generate about 1 kilowatt of electricity, which is the average demand. And there is a trial currently being conducted which will ultimately involve 10,000 homes. They should all be installed by the end of next year, and we shall look to see if there's any benefit from that. The summary answer to your question is, I don't think there are any technical cons, but sometimes there can be detailed application problems.
Okay, thank you, John. Let's give John a round of applause, please.